Hi class, today we're going to talk about standard form of a quadratic function, which is section 4-2, part 2 of your book. Our objective is to graph quadratic functions written in standard form. Alright, so we're going to convert from standard form to vertex form. It's no different, for example, than when we were changing from standard form of a linear equation back to slope-intercept form. Okay, all we're doing is manipulating our variables to fit the form that we want. Okay, so let's be reminded of what vertex form is. First of all, vertex form is y equals a in parentheses x minus h squared plus k. So in order to find everything that we need to know what a is, and we need to know what h and k is. Well, what's really nice, first of all, is that we already know what a is. A is the exact same a as the a, b, and c in standard form. So a is 2. So we already know what a is. Now we just need to find our vertex. Now, one thing I want you to remember is that h and k would be the same thing as the x-coordinate and the y-coordinate, right? And I know that's going to throw you off for just a second, so just go with me. Remember before that to find the axis of symmetry, remember the axis of symmetry is the same thing as x. Well, x now, if you remember, is the same thing as h as our the first part of our vertex. Okay, so what I'm going to do to find x, remember, is that negative b over 2a. So negative b would be negative 10 over 2 times 2. That would give us negative 5 fourths, and negative 5 halves if I multiply and then reduce it. And then if I want to go ahead and make that a decimal, which we should because we don't want to have to deal with manipulating fractions if we can get past it, that would give us negative 2.5. Alright, so now that we have negative 2.5, we will take that negative 2.5 and we will substitute it to find our y, right? That's the same thing as our y. So here we go. Y equals 2 times negative 2.5 squared plus 10 times negative 2.5 plus 7. Negative 2.5 squared will give us 6.25, and 6.5 times 2 is 12.5. And then minus 25 plus 7. Y would then equal negative 5.5. Alright, so now we've got our x, now we've got our y, which is the same thing, remember, as h and k. Okay, so now we have our final answer. And our final answer, I'll write at the bottom, is y equals a is 2, parentheses x minus h is negative 2.5, so that's a double negative, so it's going to make it positive 2.5 squared minus 5.5. And that's our final answer. Let's go ahead and do the try associated with it. Okay, and try 3 again, we have to be reminded of what our vertex form is. So that's y equals a parentheses x minus h squared plus k. All we want are a and then our h and k. A we already know to be negative 1 here. Okay, so now we just need to find h and k. So remember, we will find that by doing negative b over 2a. Negative b would be negative 4 over 2 times negative 1. That's really negative 4 over negative 2, which reduces down to positive 2. Okay, now we're going to take that 2 to find our y. And so that would be negative parentheses 2 squared plus 4 times 2 minus 5. 2 squared is 4, and 4 times a negative is negative 4. Plus 8 minus 5. So that would give us 4 minus 5, which is negative 1. So if I substitute all that information back in, our final answer will be y equals negative 1, or you can just say negative, right? Negative 1 or just negative, parentheses, x minus h, which is 2, right? Because remember, that's the same thing as h, squared plus k, remember that's the same thing as k, which is negative 1. So I'm going to get rid of the plus and just make it, make it minus 1. So this is our final answer at the bottom. Let's move on to our next example. In example 4, we're interpreting a quadratic graph. So it says the New River Gorge Bridge in West Virginia is the world's largest steel arch bridge. You can model the arch with the function below, where x and y are in feet, and the origin represents the left base of, it should be the supports. Approximately how high above the river is the arch? How long is the section of the bridge above the arch? So we're going to answer those two questions on the next page. Or let's look at the picture for the page. So on this page, what we see is an arch. Notice this is actually a parabola, right? So if you want to talk about real world context, this would be like an engineering type question, okay? So it is a parabola turned upside down. Our origin would be up here, okay? And it says this distance at the top would be the height of the arch, and then below that is 516 from the bottom of the arch to the river, okay? And so, excuse me, it asks for us to find the height of the arch to the, let me read that again. It says approximately how high above the river is the arch. So to approximate that entire part, what we'd really need is this whole section here. And I know that's really hard to see, so let me make that just a little bit thicker for you. That would be, okay, didn't mean to use a highlighter, but that whole section right there, okay? All right, so to be able to find that, the first thing we need to do is deal with the vertex. The vertex will help us out so much. So let's go to the next screen so that we can start working with the vertex. By the way, let's just move on. All right, so if we found that the vertex was 850, 361, oops. Then what that is telling us is, remember, that means that the x value here, let me use a different color. That means that the x value here is 850. And then it's telling me that the height of the arch is 361. So to find the height from the top of the arch down to the bottom of the arch, I would take the 361 plus the 516. So to answer the first question, 361 plus 516 will give me 877, or about 877 feet. So that's how tall the bridge is from the vertex down to the river. Okay, and then to find the length of the entire bridge, well, we already know what half the length of the bridge is. It's 850. That is our x value. And we know it's half because it's half the arch. It's from one end of the arch down to the vertex. So all I have to do technically is double my 850. So I'm going to do that down here. 850 plus 850, or I could say 850 times 2. That'll give us 1,700 feet. So the entire length of the bridge is 1,700 feet. And that's all you need. So let's go ahead and do the try. All right, so remember our equation was y equals negative 0.0005 x squared plus 0.85x. Okay, to be able to find the vertex, we have to do negative b over 2a. So negative b over 2a, remember that's the x, will give us negative 0.85 over 2 times negative 0.0005. All right, I'm going to put that in my calculator. So 2 times negative 0.0005, that will give us negative 0.001. And then I'm going to take negative 0.85 divided by that answer, and I'll get about, I'll get equal to 850. So if that's 850, then to find the y, I would substitute. So negative 0.0005 times 850 squared plus 0.85 times 850. I'm going to do that all in the calculator. So here we go. 850 squared times negative 0.0005. And then if I add that to 0.85 times 850, I'm going to get about 361 because it's really 361.25 in my calculator, but I'm going to put about 361. So my vertex is 850, 361. So to get the entire height, I hope this works very well, and I hope it doesn't kind of mess up the video, but here we go. Let's go back. All right, so we're going to do this again. By the way, I just realized it's supposed to be the, and the equation is y equals negative 0.0011x squared plus 0.13x. Okay, so to be able to find the height would be our y value. So if it says how high, it's actually asking for y. But to be able to find y, we have to find x first. So x, remember, equals negative b over 2a. So that'd be negative b, which is negative 0.13, over 2 times negative 0.0011. 2 times negative 0.0011, and then negative 0.13 divided by that answer would give us about 59. Okay, then after that, we're going to substitute that in. So negative 0.0011 times 59 squared plus 0.13 times 59. All right, 59 squared, and then times negative 0.0011, and then if I add that to 0.13 times 59, I get, and again I should say about 3.84. So, oops, not 3.84, and that would be about 3.84 feet above the base of the supports. So that is our answer. Remember, guys, if you have any questions, come see me for tutoring.